Let's solve exponential equations where we have different bases and binomials as exponents. So when we take a look at this here, because we have different bases, we cannot try to achieve a single common identical base. We're never going to make a 4 and a 3 look the same. We also see that we have exponents in the variables, which suggests to us that we're going to want to use a logarithm. So let's go ahead and apply log to both sides. And then let's have our binomial exponents fall forward. Now remember, when those exponents fall forward, they'll need to be in a set of brackets like so. So what's going to happen is these two exponents are going to fall forward, and now we're going to see that we have got 2x minus 1 times log 4 equals x plus 2 log 3. And now that we've got that, we did have exponents with different bases, but now we have logs that have the same bases. Both of these logs have a base 10. So next step, let's go ahead and distribute from the brackets. So in this first set here, this will become 2x log 4 minus log 4 equals x log 3 plus 2 log 3. I'm going to do a couple things. I'm going to have this 2 climb up, just the 2 and not the x. So what that's going to do is leave me with x log 4 squared, which we know is 16, minus log 4 equals x log 3 plus log 3 squared, because we also had this exponent climb up as well too. All right, now in the next step, I'm going to do 3 things, and I think you're going to be okay with it. I am going to add a log 4 to both sides. Got it? I am going to subtract x log 3 from both sides. Got it? And I am going to take this 4 squared and this 3 squared and turn those into 16 and 9 respectively. So pay attention to this carefully, because now we'll see we have x log 16 minus x log 3 equals log 9 plus log 4. All right, next step, I'm going to take a look at the left side here, and I've got two x's. What I'm going to do is common factor out that x, giving me x log 16 minus log 3 equals log 9 times 4. So you'll notice that I factored on the left side, and I've gone ahead and applied my log law on the right side where I have the arguments multiply, because I have that common log base of 10. I'm going to go ahead and apply the log law on the left side, and that's going to give me x log 16 over 3 equals log 36. Next step, I want to separate this x from the log 16 over 3, so I'm going to divide both sides by log 16 over 3. When I do that, we see that these are going to cancel here, and that's going to give us x equals log 36 over log 16 over 3. Okay, we have two options here, and it depends what the instructions say. A very popular question these days is to take the initial question, our 4 to the power of 2x minus 1 equals 3 to the power of x plus 2, and express as a single logarithm of the form log base b of a. And so if we take a look here, we can apply our change of base, and in this case, we will end up with x equals log base 16 over 3 of 36. This question is done. Or we might, if we're lucky, and I do say lucky, be asked to evaluate this one to the nearest hundredth, in which case we already have the change of base applied. All we're going to do is put this into our calculator, and we can see that this will give us approximately 2.14. And so now we see we've either expressed this as a single log of the form log base b of a, or we have gone ahead and evaluated this rounding to the nearest hundredth. Good job, good luck, and goodbye.